at this point, your book and I have a serious disagreement. Your book is going to go on to say that not every function has an inverse. And this is not true at all. Okay? In fact, I'm going to say, and since this is my class, this is log, every function has an inverse. Every single one of them do. Okay? The problem, and this is what your textbook was trying to avoid, the problem is the inverse of some function is not necessarily also a function. And we're going to see examples of this. Okay? However, the inverse of a function is not necessarily also a function. Okay? And that's the heart of what your textbook would be driving at if you were reading your textbook. Okay? So at this point, your textbook is going to go on to talk about the kinds of functions that we call one-to-one functions, and we're going to get to that at the end. But the beauty of one-to-one functions is their inverses are also functions. They're the kinds of functions whose inverse is also a function, but I want to talk about a bigger, broader kind of family of inverses. Okay? So for the most of the rest of our time, we want to talk about how do you find an inverse. Okay? So that's sort of the game. And we're gonna look at this three ways. In three different situations, three different settings. Alright, we're going to look at ordered pairs. We're going to look at graphs. And then we're going to look at equations. Okay? Those are the three kinds of functions that we're going to talk about. And how do we find their ordered pairs? Finding their inverses, starting with ordered pairs. Okay. If your function is simply a set of ordered pairs, then its inverse is what you get when you switch x and y values. And that's it. That's all you gotta do. Do y'all know how to switch two things? Then you know how to find the inverse of a function if it's just a set of ordered pairs. Okay? So let's come up with a function. How about... Oh, I can't do that. I could do this though. How about the point 1, 2? How about another point? 2, pi. And possibly another point 0, -1. Does that work for everybody? 3 points? Okay. And I know it's been a while since we talked about functions, but is this a function? Do I have any x's paired with extra y's? Each x is paired with 1 and only one y, right? So this is a function, and we could, if we wanted to, we could call it f of x. So then if I asked you, what's the inverse of that function? You would go through one by one and just switch your x and y values. So one point in the inverse of this inverse function would be 2, 1. Another point would be pi, 2. And the third point would be what? -1, 0. And that's its inverse. Switch x and y, and that's it. Okay? Now, why does this work out? Well, I don't want to go into why this works out. If you want to figure out why this works out, good, go for it. But I just want to show you that it does work out, sort of. Okay? We're not going to do the full-blown, every single itty-bitty point, but I want to show you, if those guys really are inverses, then when I take a number and plug it into one function, and then take what I get from that and plug that into the other function, what am I supposed to get back? The same exact number that I plugged in. Okay? So I'm going to do f following f inverse of 2. And if these guys really are inverses, then I'm going to get 2 back as my final answer. Okay? So this is f of f inverse of 2, right? And remember, when I'm plugging a number into a function and it's just a set of ordered pairs, I just find that x value and put down what the y value is paired with it, right? So in my inverse function, where does x equal to, the first, second, or third point? First point, right? This is x. So the y value is 1. So f inverse of 2 is 1. So then if I take 1 and plug it into the original function, what do I get? Right here, when x equals 1, y equals 2. Did I get the same number that I plugged in from the beginning? You bet. And we'll do it again. And we could do it up to like 5, 6 more times. And every time we do it, it'd work out the same. What if I did f inverse following f of 2? Because it's got to work both ways, right? So if I take 2 and plug it into f first instead of f inverse first, and this is f inverse of f of 2. So that's f inverse of, well, what is f of 2? Careful, it's not 1. Yeah, f of 2, this is where x equals 2, right? It equals pi. And if I take pi and plug it into my inverse function on the bottom, what do I get? 2. So I get the same number 2 that I plugged in the beginning. Now, I'm going to concede that you're probably sitting here thinking, so what? And that's a fair question. The so what is, if I've got inverses and I put them together, they essentially just cancel each other out, right? That's a handy sort of thing in some cases that are going to be coming up, especially when we get around to solving some equations. Okay? I want to do one more. Let's do f inverse following f of 0. If I'm plugging in 0 to f first. Y'all tell me I get negative 1? And if I take negative 1 and plug it into the inverse, what do I get? Oh, yeah. Okay. It's amazing, isn't it? All right, one more thought. Yeah, I need that space. For f of x, what's the domain of that function? Remember, the domain is just all your x values, right? So yeah, 1, 2, and 0. That's my domain. What's the range of that function? 2, pi, and negative 1. Y'all agree with me? And I think that's Keyshawn. No, it's the other guy, the mystery voice. Oh, way off. Jacob. Yeah. Do you agree with me and Jacob? Cool. So for the inverse, what's the domain? Does that sound familiar? Did y'all just get a little deja vu? And what's the range? What obviously just happened? Yeah, my domains and ranges just switched, right?